Welcome to the DIY Honda Garage channel. The DTC code P1659 indicates an ETCS control relay off malfunction. The acronym ETCS stands for Electronic Throttle Control System. This system plays a critical role in controlling the engine's throttle opening based on various input parameters, such as accelerator pedal position and engine load. The control relay essentially ensures that the throttle response is precise and efficient, facilitating seamless vehicle acceleration. The relay is typically located within the underhood fuse relay box, making accessibility important for diagnosis and repair. Working with this system requires careful attention to wiring integrity and relay functionality, as issues can lead to poor engine performance, increased emissions, or unsafe driving conditions. DTC P1659 refers specifically to a malfunction within the Electronic Throttle Control System, ETCS, particularly concerning the control relay being off. The ETCS is crucial for modern Honda vehicles, including the 2016 to 2022 Honda Pilot, allowing for electronic management of the throttle. The control relay helps facilitate communication between the engine control module, ECM, and the throttle actuator, ensuring that the throttle opens and closes as needed for optimal performance. If the relay does not engage correctly, this can lead to a host of problems, such as undesirable acceleration behavior, poor fuel efficiency, or even stalling. Thus, locating the relay within the underhood fuse and relay box becomes essential for resolving this issue through proper diagnosis and repair. There are several possible causes contributing to DTC P1659. One likely culprit is a faulty relay circuit board, as failures in this component can interrupt the circuit that facilitates throttle control. Additionally, a blown fuse, specifically fuse number A24-15A, can cut power to the relay and prevent it from functioning. Open wires in critical throttle control lines, such as the +B dBW line and IG1M IG1 dBW line, may also lead to lack of continuity and subsequent malfunction of the throttle control relay. Such issues typically emanate from wear and tear, environmental factors, or installation errors, and need to be systematically checked during diagnosis. When dealing with DTC P1659, several symptoms can manifest that may serve as indicators of the underlying issue. A poor throttle response is a primary symptom. The vehicle may hesitate, or the throttle may not open fully in response to accelerator input, leading to reduced performance. Additionally, engine stalling may occur when the relay does not function correctly, interrupting the flow of signals needed for proper throttle operation. Drivers might experience difficulties in acceleration, making it challenging to maintain speed or respond to quick throttle inputs. If the vehicle is equipped with a malfunction indicator lamp, this may illuminate, prompting further investigation into the DTC. The first step in troubleshooting DTC P1659 is to turn the vehicle to the on mode, but do not start it. This allows the system to initialize and be ready for further diagnostic queries. Next, clear the DTC using the HDS or Honda Diagnostic System, which will help reset any stored code memory. After clearing, it is essential to check for any pending or confirmed DTCs. If DTC P1659 is still indicated after these actions, this signals a confirmed problem. Conversely, if it is not indicated, it suggests an intermittent issue. This finding may warrant an examination of potential poor connections or loose terminals, especially in the relay circuit or the powertrain control module (PCM) areas. In this step, switch the vehicle to the off-lock mode to safely check the electrical components without risking an accidental short circuit or other malfunction. The next action is to physically check fuse number A24, rated for 15 amps, located in the underhood fuse relay box. Inspect the fuse to determine if it is intact or has blown. This fuse plays a critical role in supplying power to the relay circuit, and a blown fuse would indicate a breakdown in this electrical pathway. If the fuse is functional, you will move on to the next step. If not, repairing or replacing the fuse could resolve the issue. Once confirmed that the fuse is functioning, the next step involves removing the relay circuit board for direct inspection and testing. This relay is crucial as it acts as the switching mechanism that enables the throttle control system. Perform the necessary tests on the relay circuit board to ensure its operation is normal. If the relay circuit board tests out to be functional, you can go ahead to the next troubleshooting step. However, if the relay is found to be defective, replacement is necessary to restore the electronic throttle control system's functionality. In this step, it is vital to check the +B dBW line, which is responsible for supplying battery voltage to the relay circuit. Reconnect the relay circuit board after removing the corresponding connector B16P. Then proceed to measure voltage between designated test points 1, connector B number 2, and 2, body ground. This test must be conducted while the vehicle is in the off lock mode to ensure safety and accuracy. If battery voltage is present at the test points, this confirms that the +B dBW wire is intact. Should there be no voltage detected, repairs to the wiring in the +B dBW line will be necessary to restore proper operation. At this stage, the focus shifts to the IG1M, IG1 dBW line. First, it is necessary to jump the SCS line using the HDS. This allows for further diagnostic checks to take place. Disconnect the necessary PCM connector C51P to ensure there is no residual current affecting measurements. Next, check for continuity between test points 1, relay circuit board connector B number 3, and 2, PCM connector C number 4. A successful continuity test confirms that the wire is functional. If continuity is absent, repairs will be needed to rectify any open connections in the IG1M, IG1 dBW line to restore normal operations. Continuing with the troubleshooting process, the next step involves examining the dBW-RLY line. Disconnect PCM connector A, 51P, to prepare for accurate continuity measurement. With both PCM connector C, 51P, and B, 16P disconnected, measure continuity between test points 1, connector B number 1, and 2, connector A number 13. By ensuring the setup is correct, the continuity test can determine whether the dBW-RLY wire is intact. Should continuity be confirmed, that indicates the fault lies elsewhere. However, if continuity is absent, repairs to the wiring are warranted to close any gaps in this critical line. This step centers on identifying any shorted wiring in the IG1M, IG1 dBW line. Begin by jumping the SCS line again using the HDS, then proceed to disconnect both PCM connector C, 51P, and relay circuit board connector B, 16P. These actions will prevent incorrect readings during continuity checks. Measure continuity between test points 1, connector C number 4, and 2, body ground. If continuity exists, it indicates a short in the wire between the relay circuit board and the PCM that must be repaired. Additionally, replacing the blown fuse number A24, 15A, is necessary as part of this repair process. The final troubleshooting step is to check for shorts in the +B dBW line, which is crucial for the ETCS relay function. Make sure both relay circuit board connector B, 16P, and PCM connector C51P are disconnected. Measure the continuity between test point 1, connector B number 2, and test point 2, body ground. Should continuity be detected, it indicates a short in the wire that must be repaired. If continuity is absent, then the +B DBW line is functional. However, you might still need to replace the underhood fuse/relay box and any blown fuses, ensuring the relay system is fully operational. After completing all the troubleshooting steps and performing necessary repairs, it is crucial to verify that the issue has been resolved. Start by rechecking for the presence of DTC P1659 to ensure that it no longer appears. Then, it's essential to perform a test drive to assess the throttle response and overall performance of the vehicle. Any improvements in throttle functionality should indicate that repairs were effective. Confirming that there are no performance issues and no DTCs present will validate the success of the repair process, ensuring safe driving conditions once again. To prevent issues similar to DTC P1659 in the future, regular preventive maintenance is key. Conduct frequent visual inspections of the underhood fuse relay box and related electrical connections to identify any signs of wear or corrosion early. Ensuring connections are clean and secure can prevent intermittent connectivity issues that could lead to diagnostic trouble codes. Furthermore, it is advisable to replace fuses proactively, especially those associated with critical systems like the ETCS. Documenting maintenance activities also helps track any recurring issues, which can be crucial for long-term vehicle health. In conclusion, troubleshooting DTC P1659 requires a systematic and detailed approach that focuses on the electronic throttle control system. Addressing wiring issues, analyzing the relay circuit, and ensuring all connections are solid are crucial steps in resolving this malfunction. Recognizing the symptoms and working through each troubleshooting step provides clarity on the root cause and necessary repairs. The importance of preventive maintenance cannot be overstated, as it aids in prolonging the lifespan of the components and enhancing overall vehicle performance. Staying proactive about diagnostics can safeguard against more severe issues in the future and ensure that the Honda Pilot operates seamlessly. Please like and subscribe to the channel. See you next time.